All right, good morning and welcome to this week's review session. Hopefully, you are having a great long weekend and ready for the session. So, this week we covered the risk and return and portfolio management. Since we have 18 questions to go over, I will just move faster and review the concepts while we go over the questions. So, the first question asks about the mean and standard deviation of HPR on the stock prices. So, firstly, what is HPR? It is the holding period return, which measures the rate of return that is earned on an investment over a particular period of time. So, firstly, we compute the mean of HPR. The mean is given by the probability weighted average of its return in all states of the market, which is this formula here. And then we can simply substituting the value into this formula, and we get the probability in each state of the market, 0.035, 0.3, and 0.35. So we get a final answer of 14%. Next, we compute the variance or the standard deviation of HPR. So firstly, recall the variance formula is the expected value of the squared deviation here from the mean of HPR. So we first find out the probability in each state of market, 0.35, 0.3, and 0.35 here. And then we plug in the HPR in each state of the market and minus the mean of HPR. Then we get a number around 651, which is the standard, which is the variance. And then we take the square root and get the standard deviation, which is about 25%. All right, moving to the second question. We are asked to calculate the confidence intervals for standard deviation. So the information given is the mean and the standard deviation of a stock, which is normally distributed. And we are asked to calculate the 95.44% confidence interval. So firstly, I will give a quick review of the confidence interval. So in this graph, we can see that a normal distribution follows the rule here. About 68% of values fall within one standard deviation of the mean, and about 95% of values fall within two standard deviation of the mean. And lastly, about 99% of values fall within three standard deviation. So for this question, we need to calculate the 95.44% confidence interval, which fall within the two standard deviation of the mean. So we just calculate the lower bound and upper bound separately and use the mean minus and plus the two standard deviation, and we get the confidence interval between negative 40% and 80%. All right, moving to the third question. The question is about the expected return for the portfolio. So firstly, we need to calculate the expected return. as discussed previously, the expected return on an asset is calculated as the probability weighted average of its possible returns in all scenarios. We then substituting the values, we are given the probability in each state of the market is 0.2, 0.5, and 0.3. So here, we plug in these three numbers, and the rate of return in each state of the market is also given. So we can easily calculate the expected return as 7.2%. All right. The next question is quite similar, but we are asking for the expected return on a portfolio rather than a single asset. So firstly, the expected return formula for an asset is the same as before. So we can calculate the return for both stock X and stock Y as 20% and 10%. The calculation steps is given here. And the next step is very important. We need to use the expected return formula for a portfolio. This is the weighted average return of each asset in the portfolio. Here, weighted the weight on stock X times its expected return plus the weight on stock Y plus its expected return. So we first calculate the weights on each stock. Remember that we are given information that we invest $9,000 in stock X and $1,000 in stock Y. And our total portfolio value is 10,000. So the weight on each stock is 0.9 and 0.1. Then we have all the ingredient we need for the formula, so we can just plug in numbers and get a 19% expected return for the portfolio. All right, any questions for now? Let's move on to question 5. How should we consider this question? We firstly want to understand the role of gold in the portfolio. Because we know that gold appears to be dominated by stocks in terms of both returns and risk, but gold may still be held as part of the portfolio because it offers diversification benefits. Because you add in the gold to the portfolio, you are not only holding stocks or other financial assets, you are adding a diversification tools. And it also serves as a hedge against inflation because of its relatively stable value. Thirdly, it acts as a safe haven asset during periods of market uncertainty. Next, we want to discuss a bit more about the portfolio diversification and correlation. So if gold and stocks have low or negative correlation, we combine them in a portfolio can reduce the overall portfolio risk. The efficient frontier concept suggests that even assets with lower returns can be beneficial if they contribute to overall risk reduction. Next, the optimal tangency portfolio will hold gold if its correlation with stocks is sufficiently low. So that's the reason why people want to hold gold, although they have a lower expected return and variance. Okay, next, we consider why other options are incorrect. The statement for A is not correct because gold has a lower expected return compared to stocks, meaning it is unlikely to consistently outperform stocks over time. Historically, gold has served as a store of value rather than a high return investment. And for the option B, we know that gold is actually not highly correlated with stocks. In many cases, it has a low or even negative correlation with stocks. So this makes the gold as a useful diversification asset rather than a stock-like investment. So it is great to put the gold into our portfolio. And lastly, for statement C, it says that gold offers tax advantages. We know that while some tax benefits may exist for gold investments, they are generally not the main reasons for investors to hold gold. The primary reason is that it can serve as a hedge and diversifier in the portfolio, not the tax advantages. Okay, so next, question 6 is about risk aversion and portfolio selection. So we are given our agent, Susanna, can accept up to 13.5% risk on her portfolio return. And the risk-free rate is 3%. There are 3 portfolios with different expected return and standard deviation. So we're asked which one Susanna will be least likely to prefer. So the first step is that we notice Susanna's maximum acceptable risk is 13.5%. However, portfolio C already has a standard deviation of 14%, which is larger than the maximum acceptable risk. So portfolio C is immediately ruled out. And next, we compare the risk-adjusted return for portfolio A and B. The tool we use here is Sharpe ratio because it determines the increase in expected return per unit of additional standard deviation, which is a measure of the portfolio risk. So the formula is use the return of portfolio minus the risk-free rate and divided by the standard deviation. So since we are given the return on each portfolio and also the risk-free rate, we can just plug in those numbers to get the portfolio A's Sharpe ratio to be 2, and portfolio B's Sharpe ratio is 2 as well. So this indicated that portfolio A and B have identical risk-adjusted returns, and as a result, Susanna can choose between A and B based on other factors such as preference for higher return or lower absolute risk. But we know that portfolio C is strictly dominated by the 2 other portfolios. So C is the correct answer for this question. And next question is about efficient frontier and portfolio selection. The question is which one of the following portfolio cannot lie on the efficient frontier? So, firstly, as a reminder, what is the efficient frontier? It consists of portfolios that offer the highest expected return for a given level of risk. A portfolio is inefficient if another portfolio exists with a higher return and lower risk. And we firstly identify the dominated portfolio. Yeah, as we discussed, portfolio Y has a lower expected return than portfolio X and has a higher standard deviation than portfolio X. So X is dominate the portfolio Y. So we can rule out Y. So then we confirm other portfolios that are actually efficient. So for portfolio W, it has a return about 15%, but it also has a high standard deviation. While it is quite risky, it may still be on the efficient frontier because it has a high return than other portfolios. Next, portfolio X has a good balance of return, and it also has a low risk, so it can be a strong candidate for efficiency. Next, for portfolio Z, it has the lowest return, 5%, and also lowest risk, so it could be part of a minimum risk portfolio. So this further confirms that portfolio Y is dominated in this question. So moving on, question 8, it asks which statements about portfolio diversification is correct. So first, I want to review the concept of portfolio diversification. So diversification spreads investment across multiple assets to reduce the total risk of investment. There are two types of risk. First is the systematic risk. It is the risk that affects the overall market, not just a single stock or industry. Therefore, it cannot be eliminated through diversification. Examples are natural disasters, inflation, changes in interest rates, or global recessions. The other type is unsystematic risk, or we call it firm-specific risk. It refers to risks that are not shared with a wider market or industry. Therefore, it can be reduced through diversification. Examples include financial management, regulatory changes, supply chain issues, or liquidity issues. All right, so let's consider each options one by one. For option A, it states efficient diversification can reduce or eliminate systematic risk. This is incorrect because we know systematic risk cannot be eliminated through diversification. For option B, diversification reduces the portfolio's expected return because it reduces a portfolio's total risk. So this one is also not true because diversification reduces risk, but it does not necessarily reduce the expected return. However, expected return depends on the weighted average of individual asset returns, not depend on the total risk of the portfolio. So option D, The risk-reducing benefits of diversification do not occur meaningfully until at least 30 individual securities are included in the portfolio. This is also incorrect. The substantial diversification benefits occur well before 30 securities, according to the empirical studies, which suggests that 20 to 30 securities actually eliminated most unsystematic risk. But the benefits starts much earlier, before 30 individual securities. So this one is also incorrect. Finally, we look at option C. As more securities are added to a portfolio, total risk typically can be expected to fall at a decreasing rate. So here we notice that as more securities are added, total risk decreases at a diminishing rate. While the first few additions significantly reduce risk, the additional securities provide smaller reductions. Therefore, this statement that total risk typically can be expected to fall at a decreasing rate is correct. All right. Question 9 asks for the measure of risk. So the question is, the measure of risk for a security held in a diversified portfolio is which one of the following? So we know that it is not reinvestment rate, because the reinvestment risk refers to the risk of reinvesting cash flows at a lower interest rate. It is not the primary measure of risk for a security within a diversified portfolio. Also, it is not standard deviation of returns, because it measures the total risk, which includes both systematic and unsystematic risk. We know that in a well-diversified portfolio, unsystematic risk is minimized, so the standard deviation here is irrelevant. Also, the specific risk, also called the unsystematic risk, can also be reduced through diversification. So it does not accurately measure the combination of a securities risk in a diversified portfolio. Finally, we considered covariance. So in a diversified portfolio, the risk of an individual security depends on how it moves relative to other securities. Therefore, covariance measures the degree to which two securities move together, which will impact the overall portfolio risk. As a result, covariance helps determine an asset's contribution to the portfolio variance. So the correct answer is D, covariance. All right, the question 10 is about Markowitz portfolio theory. So as a review of the modern portfolio theory, any given investment's risk and return characteristics should not be viewed alone, but should be evaluated by how it affects the overall portfolio's risk and return. This is the argument from Markowitz. And the main argument of his portfolio theory is that an investor can construct a portfolio of multiple assets that results in greater returns without a higher level of risk. Alternatively, we know that starting with a desired level of expected return, the investor can construct a portfolio with the lowest possible risk that is capable of producing that return. So from the main statement of portfolio theory, we know that the focus is the effect of diversification on portfolio risk, making B the correct answer. Next, why the other options are incorrect. So for option A, we discussed before that systematic risk cannot be eliminated through diversification. And Markowitz theory focuses on reducing the unsystematic risk instead. For option C, while identifying unsystematic risk is important, the core of Markowitz theory is how diversification mitigates the risk, not just like identifying the unsystematic risk. And Markowitz's work is more focused on optimizing risk-return trade-offs. Lastly, for option D, the portfolio theory does not emphasize the active portfolio management. Instead, it's just focusing on selecting an efficient frontier of portfolios that maximize return for a given level of risk. So option A, C, and D are all incorrect. All right, let's move on to question 11. This question is about risk aversion and Sharpe ratio calculation. So the question is, which of the following choices best completes the following statement? An investor with a higher degree of risk aversion compared to one with a lower degree will demand investment portfolios with higher risk that are riskier with lower Sharpe or with higher Sharpe. So here is a note about risk aversion. Risk-averse investors prefer portfolios that maximize return per unit of risk, and they will avoid highly volatile investments and seek better risk-adjusted returns. Now we can consider each one of the options. Because risk-averse investors will avoid higher risk investments. So they will avoid option A, higher risk. Noted that the risk-averse investors will only accept the higher risk unless it is compensated with significantly higher returns than the risk in the investment. And next, higher standard deviation naturally means higher risk. So higher risk is what the risk-averse investors try to minimize. So B is also incorrect. So for option C, a lower Sharpe ratio means lower risk-adjusted return, which will naturally make the investment less attractive. Finally, a higher Sharpe ratio indicates higher risk-adjusted returns because it means that an investment is providing a higher return for the amount of risk taken. Therefore, risk-averse investors will prefer the portfolio with higher Sharpe ratio. All right, so next we want to So next, I want to make a quick note of the Sharpe ratio calculation. So it measures the return per unit of risk, as we discussed. And a higher Sharpe ratio naturally means higher return for the same level of risk, and lower risk for the same level of return. So from the formula, we can know that if we increase the numerator and keep the denominator the same, we will get a higher Sharpe ratio, which means higher return. And if we decrease the denominator and keep the numerator the same, we will get a lower Sharpe ratio. Therefore, the risk-averse investors prefer higher Sharpe ratio since they indicate better risk-adjusted performance. Okay, so let's conclude question 11. For question 12, we want to calculate the expected return and risk of a portfolio. So here we are given that we are managing an equity fund with an expected risk premium of 10% and an expected standard deviation of 14%. The rate on treasury bill is 2%, and our client chooses to invest 60,000 of her portfolio in the equity fund and 40,000 in a treasury bill. So firstly, you want to calculate the expected return. So the formula for the return of a portfolio is the weighted probability weighted average of return on each asset. So we firstly want to calculate the expected return for the equity fund. It is the rate on treasury bill plus the risk premium, 2% plus 10%, which is 12%. And then we want to calculate the weights on each asset in the portfolio. So we use the money invested in each asset divided by total investment and get the weight of 0.6 and 0.4. Next, we can substituting values into the formula for expected return for portfolio and get a final answer of 8%. Or we can express it in a dollar amount. We use the expected return 8% times the total value we invest, $100,000. Then we get it's $100,000. Then we get a dollar amount of 8,000. So next we want to calculate the standard deviation. Note that the standard deviation of a portfolio that includes a risk-free asset is simply the weight on the equity fund times its standard deviation, because the standard deviation for the risk-free asset is 0, so we don't need to write out the other term here. So since we have all the necessary information here, we just plug in these two numbers in the formula and we get 8.4% of the standard deviation. All right, so moving on to question 13. this is a true or false question, so let's just consider each option one by one. So option A, stocks with a beta of 0 offer an expected rate of return of 0. So we know that in the capital asset pricing model, a stock with expected rate of return of 0 indicates a beta of 0. It does not imply a return of 0. Instead, it implies an expected return equal to the risk-free rate here. So in other words, a beta of 0 only implies the expected return equal to the risk-free rate, not a 0 expected rate of return. Option B, the CAPM implies that investors require a higher return to hold highly volatile securities. This is also false because CAPM states that investors require a risk premium only for bearing systematic risk or the market risk. Therefore, total volatility, which is measured by the standard deviation, includes both systematic and diversifiable risk. And for option C, it states that you can construct a portfolio with a beta of 75 by investing 75% in treasury bills and 25% in the market portfolio. So we recall the formula for portfolio beta is here. The portfolio beta is the weight on equity investment times the beta on equity plus the weight on risk-free treasury bill times the risk-free rate. Given that the market portfolio has a beta 1 and the treasury bill has a beta 0, and assume the correct allocation, we can plug in numbers to get a portfolio beta to be 0.75. Therefore, we will get a beta of 0.75, not 75 as stated in option C. So C is also incorrect. Okay, let's move on to question 14. We are asked about the fair return for each company. We are given the forecasted return, standard deviation of returns, and beta of each company. So as a reminder, the CAPM equation is given by the expected return of stock I is equal to the risk-free rate plus the beta of stock I times the market risk premium. So because we know the risk-free rate and market risk premium, the only thing we are unsure about is the beta of each stock. So let's just calculate the expected return for each company by plug in different beta values as given in the question, so we can get the fair return for each one. All right, so let's move on to question 15. The question is, characterize each company in the previous problem as underpriced, overpriced, or properly priced. So firstly, the fair return of a stock is given by CAPM. And so let's calculate the stock valuation using CAPM for each company. First, we know the required return is 13% for company A, and has a beta of 1.5. The CAPM forecasted return is 12%. Because the forecast return is less than required return, the stock is overvalued. Next, the required return for the second company is 10%, and the forecast return from CAPM is 11%. Because the forecast return is greater than the required return, the stock is undervalued. So moving on, we are asked about which option is the security market line depicts. So here's a review of the security market line. The security market line represents the expected return of a security based on its systematic risk. It is also derived from CAPM. The security market line has an intercept equal to the risk-free rate and a slope equal to the market risk premium, as shown in this figure here. All right, let's consider option A. A security's expected return as a function of its systematic risk. So this is actually what the security market line depicts. It actually directly plots expected return against beta. The beta measures the systematic risk. So here is the graph of SML. It shows the required return for a given level of risk, ensuring investors are compensated for taking on market risk. For option B, the market portfolio as the optimal portfolio of risky securities. This statement describes the capital market lane, not the security market lane. The key difference between a CML and an SML is what the x-axis depicts. So in the capital market lane, it is total risk or the standard deviation. However, in the security market line is the systematic risk. So this is the key difference between these two lines. All right, so moving on to option C, the relationship between a security's return and the return on an index. This statement actually describes the security characteristic line, not the SML. So the security characteristic line is obtained from regression analysis between security returns and market returns. Option D, the complete portfolio as a combination of the market portfolio and the risk-free assets. This statement refers to the capital market line again, not the security market line. The capital market line shows how investors can mix risk-free assets and the market portfolio to achieve different levels of return and risk. All right, so next one is just a question based on the concept of CAPM. The capital asset pricing theory asserts that portfolio returns are best explained by which of the following? So, based on the concepts in CAPM, the portfolio returns are best explained by its systematic risk, which is measured by the beta in CAPM. On the other hand, the security market line illustrates this relationship, showing that expected return increases with higher beta. Therefore, answer C is the correct choice, the systematic risk. All right, so the last one is question 18. So we want to calculate the expected return and alpha for each of the stock given, and also want to identify and justify which stock would be more appropriate for an investor who wants to add this stock to a well-diversified equity portfolio or hold this stock as a single stock investment. So in part A, we want to calculate the expected return using CAPM. The formula is the same. We've seen this several times. For for stock X, we know the risk-free rate is 5%. The beta for stock X is 0.8. And the market risk premium, we use the forecast return 14% minus the risk-free rate 5%. So we can calculate the return for stock X is 12.2%. And similar thing for stock Y, the expected return is 18.5%. And next, we want to calculate alpha. So alpha is the difference between the forecasted return and the expected return from CAPM. So it equals to the forecast return minus the expected return here. So we have the information for forecasted return for each stocks from the chart, 14% and 17%. And we want to minus the expected return from CAPM. We calculated in the previous slides here. And we can get the alpha for these two stocks. For part B, we want to first consider which stock is preferred for a well-diversified portfolio. So the relevant measure for this part is the excess return alpha. Stock X is preferred in a well-diversified portfolio because it has a positive alpha, meaning it offers a return above what CAPM predicts. However, stock Y has a negative alpha, meaning it is overpriced relative to CAPM expectations. And next, we want to consider which stock is preferred for a single stock investment. Here, the risk-adjusted return is the relevant measure. So we want to calculate the Sharpe ratio first. The Sharpe ratio for stock X is 0.25, and for stock Y is 0.48. The Sharpe ratio for the market is 0.6. We can get all the necessary information from the previous chart and calculation. So we know that the stock Y has a higher Sharpe ratio than stock X. So it is a better choice for a single stock portfolio. Although we notice that the market Sharpe ratio is the highest, which is 0.6. But if we only want to choose one single stock, the stock Y will be better in this case. All right, so that concludes the wrap-up quiz 6 questions. And any other questions for now?
No, thank you.
Okay, if not, then let's end the session here, and I look forward to seeing you next week.